going to be applying the law of sines. So let's take a look here. The law of sines, recall, is little a over sine of big A, which is equal to little b over sine of big B, which is equal to little c over sine of big C. Alright? This applies to a general triangle that is not necessarily a right triangle, okay? Something like this, we can call this A, B, little b, C, little c, okay? So it's a relationship for an arbitrary triangle like that. Now, let us apply it. Let's say we have a triangle like so. Alright? It's a non-right triangle. Over here we're given that this angle is at 46 degrees. This angle is at 63 degrees. And this angle is unknown. Now this leg length is given as unknown over here, across there, unknown, and we're given that little c is equal to 56. This could be 56 inches, it could be 56 miles, it could be 56 light years. The units doesn't matter. We just leave it as 56. And if it's in inches, then it's in inches. If it's not, and then it's not. So we are interested in finding this little a, this little b, and this capital B right here. So in these problems, when you're presented with unknown parameters for a general triangle, and it is a side, and an angle, we typically call this angle, side, or a side, angle, side. Okay, but here we have two sides that are unknown and one angle. Oh, well, I think I've done it incorrectly here. We don't talk about the unknowns, we talk about the knowns. So we're given an angle, and a side. So it is AAS. It is whenever you are given two angles and a side. So this is the AAS case. Alright. We will use the law of sines in order to solve for these parameters. Okay? How are we going to do that? Well, this equation up here is the law of sines, and it holds for any triangle, and so it holds for this triangle. So I could rewrite all of that stuff up there as replacing it with A. We don't know A yet, but we know sine of capital A. Since A is here, the opposite is sine of 46 degrees. Alright, so that's going to be equal to little b. Well, we don't know what that is, but we do know sine of capital B. And that is actually, we don't know that either. And then let's go with little c. That's 56 divided by sine of capital C. And we know that one, that's the opposite to here, 63 degrees, sine of 63. Alright. So this term right here is all unknown, but this term and this term have known quantities. Notice 56 is known, and sine of 63 is known when you plug it into your calculator. Sine of 46 is known when you plug it into your calculator, and side A is, and just the little a is unknown. So I can set this piece equal to that piece and solve for the unknown little a. Like so. Okay? Really, if this equals this, which equals this, then I just set these two equal like that. Alright? We just kind of forget about that middle equality, because we don't need it for our purposes. We're looking to solve for each of these pieces. And so let's first off address what this little a is. Multiplying both sides of the equation by sine of 46 allows us to get that implies I have a is equal to 56 sine of 46 all over sine of 63. Alright? And whenever you plug this into the calculator, you can get a numerical value. And that numerical value ends up becoming 45.2. So I'll put this right here. And I'll put it in a box because that's what A is. A is approximately 45.2. Alright, so we've solved one of the sides, so we can cross this one out. Now we gotta find, now we gotta find the rest of the parameters, that is another side and an angle. So let's actually delete some information here. Alright, to clear up some board space, we notice that the sum of the interior angles of a triangle, at least in flat Euclidean geometry, is 180. Meaning 46 plus 63 plus this unknown value for capital B should add up to be 180 degrees, correct? At least in flat Euclidean space, this is true. So in order to solve for B, we could actually say B is 180 minus 46 minus 63. And lo and behold, that allows us to determine what the value of B is. Okay? It actually ends up being 71 degrees. Alright? So now this is no longer unknown inside the triangle. We know that we can call that 71 now. Aha! We had 3 unknowns, and slowly we've chipped it away, and now we have only 1 unknown. Alright? Our last unknown is what is little b. Okay? How do we find that? Well, law of sines will allow us to find it. Because we know what A is, and we know what C is. We could either use any of those to solve it. So we could use this one, B over sine of capital B is equal to little c over sine of capital C. Notice that we don't know what B is, but we know what capital B is now. It's 71, so this becomes sine of 71 in the denominator. That's equal to little c, which is 56, divided by sine of capital C, which we know is 63 degrees. Now we can algebraically solve for little b by multiplying both sides by sine of 71. So this implies that little b is equal to 56 times the sine of 71 divided by sine of 63. And whenever you plug this into your calculator, you will be able to compute what the numerical value of little b is. And upon doing that computation, you should result with, let me look up my calculation here. You should result with the value 59.4. Okay, so I'll put that in a box. So notice now, we were given a triangle with 3 different unknown pieces. It was an unknown side, and an unknown angle. And then utilizing the law of sines, we're able to solve for each of those components. Okay? So when you do problems on your own, make sure you know how to do this.